Okay, a system of equations. What is it? It is when you have two or more equations using the same variables. So something like x plus y equals 4 and y equals 5x minus 3. Something like that. That is a system of equations. The solution to the system is the point that satisfies all of the equations. So if you have a point that satisfies both of those equations, that is called the solution. Okay, and the solution will be an ordered pair, an x and a y. When graphing, you will encounter three possibilities. You will have one solution, meaning their two lines intersect at one specific point. You could have infinite solutions, where if you graph the two lines, they are the same line, and so every single point on that line would work, giving you infinite solutions. Or you could have no solution. If you had two lines when you graphed them and they're parallel, that would be no solution. Okay, so looking at each example, intersecting lines. This one right here, you have the two lines drawn, so this is your system of equations. Here's the graphs of both of them. You graph them and they meet right here at one point, so the solution is the point 1, 2. On the next page, you see this one right here. These two lines are parallel, okay? This line and this line, when you graph them, they both have a slope of 2, up 2 over 1, up 2 over 1. The y-intercept on the top line is 2. The y-intercept on the bottom is 1. So here's your system right here, 2x plus 2 and 2x minus 1. Therefore, with the same slope, different y-intercepts, they never intersect. There is no solution. And yes, you can write that like that. Okay. Next, we have if you graph and they are the same lines. Okay. So it ends up that you're graphing this line, and that can take on any number of different forms. But when you graph that line, you graph both equations, you get the same line. Slope is the same, y-intercept is the same. You would write that there are infinitely many solutions, and that's what it looks like. Okay, so let's do an example. There's a you try just talking about the solution, so go ahead, pause, do that, and here's an example. So, find the solution to the system. So the first one, 2x plus y equals 4, that's in standard form. I'm going to graph that using x and y intercepts. Alright, so when my y is 0 for my x-intercept, when y is 0, I am left with 2x equals 4, divide by 2, I get x equals 2. So I have the point 2, 0. And then when x equals 0, I am left with y equals 4. So that's the point 0, 4. So that's right here. So there's my first line. Okay. My second line, x minus y equals 2. Again, that's in standard form. So if I look at my intercepts, when my y equals 0, I'm left with x equals 2. So that's the point 2, 0. And when x equals 0, I'm left with negative y equals 2. So when I divide by negative 1, I get y equals negative 2. So 0, negative 2 is right here. Here's my line. If I could draw them straight, they would match right there. So my solution is the point 2, 0. You need to write that out as your solution point. Okay, when it says find the solution, you write it out, the point 2, 0. Okay, let me do another example. Sorry. Example 1 here is, good slide right here. One thing I forgot to point out, you do want to check your answer, okay? I got the point 2, 0. So what you want to do is check that algebraically, plug it in. 2, plug x in here, plug y in here. So 2 times 2 is 4 plus 0. 4 plus 0 is 4. So yes, that checks. And when you plug it on the bottom, x is 2, y is 0, 2 minus 0 is 2, so yes, that checks. You do want to make sure you check your work. Okay, next example. This one right here. The first one, y equals 2x plus 3, and hang on, I need to move this up a little. so I can see the graph. Okay, y equals 2x minus 3. That one is slope-intercept form, so negative 3 is my y-intercept. I plot that. 2 over 1 is my slope, so up 2 over 1, up 2 over 1. So there's my line. The next one is, you know what, I'm just going to add this 2x over. So I get y equals 2x plus 1. Okay, on this one, my y-intercept is 1. My slope is 2 over 1, so up 2 over 1, up 2 over 1. What happens here? Do they meet? No, they are parallel, so there is no solution. Okay, no solution at all there. All right, I believe from there, we need to check it on the next slide. Sorry, we check. I have no solution. All right, and if you look at it, when I solved the second one, you saw that the y-intercepts were different, the slopes were the same, so there is no solution to that one. Okay, there are 2 more U-tries, and that's it for this topic.